VT and IA. Right? That's the move. So if I'm going to calculate the torque, basically I calculate the EA dot, right? So how much is the EA? VT minus RA plus RF IA. How much is the VT? 120, right? 120 minus 1.2 times, how much was current? 12 amps, right? So basically, this one is going to say, this is a 105.6. So I know my EA, right? I need to calculate the torque. How much is the torque? EA is 105.6 times, how much is IA 12 divided by omega is how much? 600 RPM. I should convert it to what?
Radian per second.
Radian per second. So this one is going to be 20.72. Yeah. So part A was simple. Let's go to part B. Part B. N is this much. I want to calculate IA and P, right? Let's write this equation. We can say part B here. E is a K flux omega, or is a K F IA IF omega, right? So E1 over E2 for two different conditions. There's going to be IF1 over IF2 times omega 1 or over omega 2, right? Or I can say IF1 over IF2 times N1. I don't have to put the radian, I can put the RPM for both of them, right? If for both of them I put the RPM, it's still correct. Now, so, and because this is a DC machine, it's a series machine, so he's asking me to calculate the current, right? He's asking me to calculate the current. So I can say E1 over E2 is IA1 over IA2 times N1 over N, right? From part A, I know how much is E1? 105. How much is the IA1? I calculated or not? Yeah, 12 amps, right? How much is N1? 600 amps, 600 RPM, right? Now, part B said N2 is how much? 2400. Now I have two unknowns. If I can somehow find another equation, I'm done. I have one equation here and another one somewhere else, so done. So let's use this one first to find the relation between E2 and IA2, right? So E1 is a 105.6 over E2 is equal to 12 times IA2. These are EA2, I'm calling them E1, EA2. IA2 times 600 over 2400. So if you solve this one, EA2 is going to be 105.6 over 3IA. One equation. Right? Now let's go for the next equation. What's the next equation? dt is equal to RA plus RS times IA plus TA2, right? Just write it down. dQ is equal to RA plus RS IA2 plus TA2. Alright? Let's replace TA2 from here. So it's going to be 120. Was it 120? Yeah. Is equal to how much is RA RS? 1.2 IA2 plus so IA2 is going to be 3 point. So IA2 is done, right? How about 4? Calculate the EA2, right? EA2 is I don't know, whatever it is, right? Now, how much is it for?
EA I over omega.
Exactly. EA, I don't know, how much is it? EA2, how much is here? Times 3.23, and this one is 2400 times 2 pi over 60. Okay. God is cool to learn me to do the truth with you. I want to apologize, you know, guys, bring you here Sunday. I took 2 of your Sundays. When my mother passed away, I have to go through my contract, you know. That was the main reason, you know, I had to do this. And I'm sorry to bring you guys, you know, working these Sundays, you know. I didn't have any other choice. I want to cover my course, and I have to be gone for 10 days at least, you know. That was the reason I was working there. Sorry. I'll see you Tuesday. Tuesday we'll start the induction machine, put in the discussion session. I'm going to solve one more. I'm going to give you a little bit more time for the homework. I'll announce it, you know, bring it back Thursday because I'm going to work one tour on the rotation machine because you had that one in your homework. So what you need to figure out how we're going to give you to sign for your homework. Homework 2. We're going to extend it to Thursday, but I'm not here Thursday, you know that. You know. You need to send it with Fanfare, you know, make sure to not later than Thursday afternoon, you are going to hand it to the Fanfare, you know, because I'm going to solve one more example also on that, you know. Tuesday afternoon, I'm going to solve the Hoover starter and one input calculation for rotating machines, the one we had in chapter 3, you know, energy, co-energy, input calculation, and you will have a little bit more time if you want to spend a little more time. Midterm is also the homework. End of homework. No game.
Very good, huh? Good, man. Where you going now? Where you going now? I don't know, man. Probably for I broke my leg once.
Like